Today, single axis trackers are coming to Rooftop Solar. I'm Tim Montague, your host. Welcome to SolarWorks for Illinois. Today, my guest is Austin Williams. He's the Vice President of Business Development and co-founder of a company called Point Load Power. Welcome to the show, Austin.
Thanks for having me, Tim. Great to be here.
When I first saw your product, I thought, wow, a double axis tracker for rooftop, that's very unique. But it's a single axis tracker, which is also unique because most of our rooftop solar here in the United States is ballasted fixed tilt. We either go 5 or 10 degrees, fixed tilt, ballasted, meaning it's way down to the roof. Generally speaking, we can do attached or partially attached. Attached solar is more common in California because of the earthquake risk there. And I've done a couple of attached projects here in the Midwest. The most common objection to attachments, of course, is, well, you're putting a hole in my roof. And to that I say, well, guess what? You already have a bunch of holes in your roof, so don't worry too much about that. Putting holes in roofs is a standard operating procedure, and roofers know how to do this and make it not leak. So anyway, let's give our listeners some background on yourself. How did you get into solar, Austin?
Yeah, I've been in solar for almost 12 years now. I started in the Midwest as well, not too far from you, South Bend, Indiana. And did a lot of projects on the East Coast and in the Southeast. Originally, I was an installer going on rooftops in Indiana and installing residential systems, and then eventually started doing development and worked for a EPC out there called Inovateus Solar, where we developed some of the first utility scale projects for Georgia Power and IKEA, as well as many others out on the Southeast. A lot of my projects had started going to tracking. All of the utility scale stuff that we did really started to shift over, and trackers were there to help get as much value as possible out of every system installed. And always wondered why there wasn't an option like this for rooftops. Came across PV Booster and the team that created that out of Edison Microgrids at IdeaLab, and wanted to join. I thought it was a really fascinating product, and was really interested in propagating C&I solar across the country, which, as you know, is traditionally lagged behind some of the other developments. So that's really how I got into it, and I've been in energy since, and really love the solar industry and what we're trying to accomplish.
Well, congratulations for finding your way from South Bend to Southern California. I was born in Indiana, in Bloomington, and so I'm a Hoosier by birth.
Yep.
I left there when I was 2 years old, so I can't say I grew up there. But and we know Inovateus. Inovateus has certainly made a mark here in the Midwest as a renowned solar developer. They do many educational projects. In fact, they're doing a project here at the University of Illinois, a 13 megawatt project.
Wow.
And yeah, as you mentioned, trackers came to utility scale. Most of the community solar and utility scale solar happening, certainly in Illinois now, is single axis tracker. And the basic premise is you get more energy per square foot of solar array, bottom line. And you can get a 10 to 15% boost in your energy production with trackers. The idea being that you can get, the same amount of energy for less equipment. And this applies to your product quite nicely. I've done a side-by-side analysis with my project called Simmons Knife, where that was a 434 kW DC project. We did 5-degree tilt, fully attached, because it was a re-roof and solar. And when you change the project from a fixed tilt to PV Booster, which is a single axis tracker, then you can only install half the number of panels. And you're going to do a screen share here in a minute so you can show us the product, but half the number of panels, same amount of energy coming out of the array, because the panels are tracking east to west, following the sun, right?
Correct.
And you're tilting those at 30 degrees. So it's an optimal all year round tilt. And and then you're fixing these little tripods to the roof that the panel is attached to, and away you go. So it's a just an alternative play, and probably good for some projects, and maybe for some others. So we will get into that. But tell us a little more about point load. What are point load's origins?
Sure. Yeah. Point Load Power is technologies company, a solar technologies company, and we came out of an incubator called IdeaLab out in Southern California, run by a gentleman named Bill Gross, who's been prolific at launching tech companies since the 90s. He's really created something special in Pasadena, and has always had a focus or a number of companies in the clean tech space. And you can probably read about a lot of things that he's doing now that are really world-changing ideas. And one of his ideas were these miniaturized tracking systems. So when folks think about tracking, they usually think about large gear drives driving a quarter meg of panels, and it just didn't really translate to the rooftop. And I think that's why one of the reasons that kind of held the tech back. But Bill and his team designed something really special where we're trying to get down the cost of those and interface with the roof safely, which was the genesis of PV Booster. But we've been operating in out of IdeaLab for over 4 years now, and our products gained a lot of steam, and we're looking to really drive some market adoption here with PV Booster, as well as some other technologies that can really help in the transition from buildings becoming their own clean power plants. And we're working on some other things, as well as a software solution for billing. And something that can just really help this space take off, which, like I said, has traditionally lagged some of these other areas. So that's our mission at Point Load, to help customers and builders really see the power and energy for their buildings.
Great. Well, why don't you show us what we're talking about? Let's take a look at this product.
Sure.
And it has some roots in the CSP world, right? In the
Correct.
concentrated solar power industry.
Yeah, so Bill's made some pretty big marks in CSP, and this originally was very similar design to something they're using at a company called Heliogen, which is driving very high temperature heat to replace some of the heat required in industrial processes, as well as hydrogen development and things like that. Some pretty interesting things. But Bill's main goal was to drive down the cost of the heliostat, which is by far the largest cost in the concentrated solar. And as these got smaller and smaller, we said, hey, this looks like it could fit a 72 cell panel on it. And obviously the PV market is much more distributed and mainstream accepted. So that's kind of where the origin of the idea came from. And I'm just going to share something we're working on right now. It's not released yet, but it will be available pretty soon, which is a virtual reality look at PV Booster, as well as an augmented reality function where you can actually look through a phone or a mobile device and set these up on rooftops or wherever you're interested in having PV boosters. So as you alluded to, Tim, this is our tracker, and it sits on a tripod, which is a way to make it very stout, strong, but low form and easy to interface with the rooftop safely. And you can see the mechanical attachment there, and the panel and things like that. But this is really different from what most people are seeing, whereas you're used to horizontal axis trackers that are not tilted in any way. And so a lot of the comparisons you see on the utility scale about what the benefit of tracking is, well, the key question is, what are we comparing to? And when we're comparing to the rooftops at a 5-degree tilt, this really functions quite a bit different. And as you can see, it rotates along the tracks azimuth or along the east to west axis, and is always tilted at 30 degrees. So the difference between those two are really what leads to some of these incredible production boosts that we've seen, up to 70% more energy or more revenue out of every panel that you install. And like you said, Tim, because of spacing, these systems need more space, and that usually leads to systems being about half the size, up to half the size as a normal fixed tilt. But sometimes it's about 75%. It really depends on what we're comparing to, like I said. Um, I'm going to remove the other components here just real quick so you can actually see what you're getting when you get a PV booster. And we've worked really hard to make this robust, strong, and simple. So there's three main subsystems that we're looking at. The first is the H-frame that holds the panel, and 72 cell panels best. The highest capacity, the better, because you're buying one of these for every panel, similar to a microinverter or an optimizer. The second main subsystem is this actuator drive, and that's really the proprietary IP that was developed out of IdeaLab by our company in Heliogen, which is a very low power but robust way to track the sun and track azimuth throughout the day. And then the third subsystem is the tripod, which obviously the three-legged stool concept is going to be able to interface with these flat roofs and really hold, disperse the weight into the roof as we resist wind and things like that. So that's PV Booster.
And let's walk through the life cycle of an installation. Obviously, you're attaching these tripods. The tripod has to attach to purlins, is that right?
Correct. Yeah. These need to go into some substructure under the roof. Mechanical attachment uplift forces for wind can be high in areas, and we recommend that uplift requirement to attach to any kind of purlin that we have up there. Out in Southern California, there's a lot of wood construction, wood rooftops. Those are really great, but we can interface with any beam or purlin. And those tend to be about 8 foot on center, which is kind of, in our design guide and things, a general rule of thumb for when we say how many PV boosters can go on a rooftop, either using Helioscope or whatever design software, approximately 8 foot on center. And that's really driven by the building and the building construction.
What if the purlin isn't wide enough, though? It looks like I can see how, the two east-west legs could sit on the purlin, but how does the front leg then sit on the same?
So about 10 inches from the intersection, we can get all feet on a purlin and the uplift mechanical attachment on a purlin. But the down forces are really a secondary effect. The feet don't necessarily always need to sit on a purlin. It depends on the rigidity of the roof. Some concrete roofs, there's a number of different options where the down forces are not as critical. Really, it's about the mechanical attachment being on the purlin, going into the purlin with some 2 1/4 inch lag bolts is the main consideration for the design.
So that center support is also connected to the roof?
This is the only thing that's connected, actually. So one mechanical attachment is bolted in. The feet are just for stability and downforce dispersion. So those are not actually mechanically attached. Simply these two right here.
Well, that explains that then.
Yeah, great question.
And then you're using a microinverter, so the whole system is AC. And
yeah.
And is the array powered? Are the motors powered by the array, or are they powered by the facility power?
Currently, they're powered by facility power. We're working on making PV Booster a power electronic, which would allow them to be panel powered. And that's underway for our next generation. But currently, they are powered by the building. And like you said, the conversion device can be a microinverter right there, mounted on our system. We have different points on the H-frame that allow for mounting. What you're seeing here is actually an optimizer that's mounted on the system. And so these are still DC cable runs and go to a string inverter. But there are options. Obviously, what we're trying to do is allow designers to design systems how they're comfortable, use the equipment they're comfortable with, the panel, the conversion equipment, things like that, and really allow PV Booster to interface with most of those. But in this case, yes, we often use microinverters or at least optimizers just to maintain, our goal is to produce as many absolute kilowatt hours as possible. And so some of the design choices may be a bit different, but that's why we use optimization.
And when does it pencil, so to speak, to use point load versus a fixed tilt project?
Sure, there's a number of scenarios. We're really targeting the C&I space, and especially the low energy intensity, so energy use per square foot space. We tend to win all the time. And then of course there's many C&I buildings that are kind of a toss-up, but low level offices, warehousing, dry storage, cold storage. We've got a notable project there and really looking to explore that vertical a lot more. Those all really make sense when there's large flat rooftops and plenty of space available. Other situations include when kilowatt hours are the most valuable metric to measure a project's return. Sometimes it makes sense to put as much DC absolute capacity out there, but in cases with feed-in tariffs or SREC programs or different things where you're trying to produce as many absolute kilowatt hours as possible, PV booster can be a good option. Also, electrical limits. Anytime you go in and the AHJ or someone says, hey, you can only have a megawatt here, or 500 kW or something like that, where they come in and they artificially limit the system sizes, if you can install a certain number of panels, we can get more out of every panel. So in the case for Chiquita Brands, which we did in Oxnard, California, they had plenty of space. And they were under a California program, net metering 1.0, NEM 1.0. They had 1 megawatt AC limit. So we went in with the same amount of equipment and with all the space being available, produced that many more kilowatt hours. So I'd really say the large, flat, commercial and industrial spaces is where we really shine.
But that's true of any rooftop solar.
Fair enough. Fair enough.
Do you have any photos of the Chiquita project?
Not something I can bring up right here, but maybe there's something I could send you that could go along with all this. But yeah, there's definitely stuff on our website about Chiquita, and we put together a case study as well.
Okay.
And let me drop this off for now. So we'll go back to you and
I see you have a story on bifacial modules on your website also. Bifacial is all the rage. How does your product compare to others for bifacial?
Really well. So we were actually quite surprised by this. Well, not surprised, but we were curious to figure out whether this would be a benefit, seeing as the industry is going that direction. And we were really pleased with the results, which was kind of the basis of our production claims that we're putting out there right now, which is up to 70% more energy out of every panel. And what that is referring to is a specific case study we had in the high desert here in a place called Victorville, California, where we installed bifacial panels and got significantly more energy out of them. Our tracking system, again, it all depends on what you're comparing to. So if folks are interested, I'm happy to introduce them to the product and talk about that. But the single axis tracking itself has seen 30-40% more energy out of every panel, and the bifacial is the wild card. If you've been following kind of the studies and the tests that they've got going on and understanding, quantifying the benefit of bifacials, there's 4 key factors that really boost the bifacial production. And one is height, one is tilt, one is spacing, and then one is ground cover. And so for height, as you could see, actually, I'm going to throw that back on. As you could see, our height is higher than traditional fixed tilt significantly. So we are producing, getting more reflective light. Our tilt at 30 degrees, much higher than most of the rooftops. So there's a benefit there. We have the spacing that we described already to not impede any motion as it tracks. So there's another benefit point. And of course, the ground cover is as good as it can get with very high 90% reflectivity white rooftops. So we're seeing that a system like this is
There's nothing
getting.
showing on the screen, by the way. I don't know if that's
Oh,
intentional.
sorry about that.
There you
So,
go.
okay, great. Well, like I said, height, tilt, spacing, and reflectivity, and we really check all those boxes as far as the benefits to bifacials better than the fixed racking we're seeing out there. Higher up, spaced out, tilted at a high angle, and then the reflectivity of the rooftops is great. So this is combining to give us almost as much additional energy out of every panel as tracking itself. And we think that this is going to be a great opportunity for anybody interested in bifacials for rooftops. But of course, monofacial panels have a pretty good advantage as well.
Yeah. So for comparison, I'm going to share my screen and show your drawing of Simmons Knife. This is a project we did in the Chicago suburbs. The dark squares are the actual panels as designed. This is a 5-degree tilt project. And then the point load layout is the light blue squares. And you see that the point load is basically using every other row compared to the fixed tilt project approximately. And it does turn out to be about half the number of solar panels on this roof. But with fixed tilt, because this is 5-degree tilt, we have insulation of about 1100 kWh per kWp. So insulation is just a measure of how productive a solar panel is at a given location. In Illinois, we see 1100 to 1400, and then getting up to 1500 with single axis trackers for ground mount. And your product, in this case, is producing insulation of over 2000 kWh per kWp, right?
Correct. And that's using the bifacial effect as well. But
Okay.
yeah, so it's pretty significant we're seeing, and the kilowatt hours per kilowatt power, that is basically the benefit of PV boosters. So when yield or insulation really is the driving factor for project economics, this is a good opportunity to look at what PV booster could do.
And what kind of information do you have about durability? How is it holding up for wear and tear?
Really great. So we've got our reliability testing and documentation that we've put together about the life of the system, and it's significant. We've seen our system, last the equivalent of nearly 450 years in accelerated life testing. Now, nothing is a substitute for actual real-world testing, which we're getting every day. But that accelerated life testing with salt spray and freeze and thaw cycles and everything that we've really put it through to make sure this thing is robust. A lot of our engineering team comes from aerospace, comes from, products with incredible longevity. And we've tried to make it simple as well as strong so that it will last as long as the solar panels will, and as long as the solar system is needed to last. So that was really our goal. And then independently, we went through the testing and verification to UL standards by CSA, which we achieved earlier this year, which was a really big milestone for us. But like I said, we're collecting that data all the time, and with power electronics, we see a lot of the issues being like infant mortality issues that come up very quickly, whereas the stainless steel and everything that we use, or galvanized steel, that we use in our system, has incredible longevity. As long as it's installed properly, we're good to go for many, many years.
And then the all-important cost. How does it measure against fixed tilt for cost?
Yeah, again, totally compares or depends on what we're comparing to, but we've seen our system be between about 20 and 30% increased cost on all-in system basis. And just like tracking premiums, we're talking about a higher one-time capex investment for year-over-year increases in energy production and yield. And so that's really where we believe we can drive the lowest LCOE for rooftop projects that we've looked at is in that production. But the 20 to 30% boost is a good rule of thumb. And generally, a lot of that obviously is EPC, designer, and installer decisions as it relates to equipment. But happy to walk through a project comparison or look at some projects that you think could be a good benefit, and see how this shakes out as far as cost to benefit.
Yeah, I mean, I have to say, your uh, if your modeling of the Simmons project was accurate, you're coming in a lower installed cost for the same kWh production, and so it is certainly worth a look. And I look forward to digging into a project. And the engineering is probably the greatest area of sensitivity to C&I solar installers. Rooftops are always a sensitive matter for project owners. We want to maintain the roof warranty. We don't want to give anybody discomfort about the viability of their roof.
Right.
But at face value, it's worth a look, and you have made a case that this is cost effective, and there's no reason that I see why this isn't going to get traction other than momentum, right? People just don't know about it, and it just takes time.
Yeah, I appreciate that, and that's why I also appreciate you inviting me here and taking a look yourself, because we're definitely in the process where we're getting the word out. We are looking for market adoption and folks that have the rooftops to put these out there. But I think it's the results are speaking for themselves, and we've spent a lot of time collecting data. So that's my job over the next couple of years, is just really make sure we're known.
Is there a video from your collection on your website that we could show our listeners that would be useful, like the rooftop solar tracker, the top right one there? Is that a good one?
Yeah. Let me, I'm not looking at what you're looking at, but any video up there should be pretty good. Well, that might have been a new one that we put together. Let me see real quick. While the original video that we put together, that's PV Booster Rooftop Solar Tracker you mentioned?
Yeah.
Yeah, I think that'd be a great one to show.
Okay. Let me share my screen. Mm-mm.
And it's got a great baseline, so I don't know if you can crank that. It should be noted that that's our Gen 1 product, but
What are you saying?
it should be noted that's
Oh,
our
I
Gen
was
1
hearing the
product.
audio. So there's Bill Gross. The tracker is larger than you anticipate um, from your little engineering drawing, but makes sense.
Yep, big enough to hold a
As
panel.
solar panels get bigger and bigger, the structures that hold them have to get bigger too.
Yeah, so this was the dual axis version that we were working with, which we realized, out of
So how
some
long has the product been in the market?
4 years. And this is the Chiquita banana facility.
So remind us, Austin, how long has PV Booster been in the market?
Oh, can you hear me? Sorry.
Can you
It's
hear me?
I can hear you.
I
I
can't
guess.
I can't hear you very well.
Okay. Um, how about
Okay.
now? Okay, good.
I had to
Yeah.
turn up my volume. I had to turn it down for the video, and now I'm back. Anyway,
Oh, good. So PV Booster has been in the market over 4 years now. We're going on 5 pretty soon. We debuted in at SBI actually about 5 years ago.
okay.
So yeah,
And
we've spent that time really getting through the due diligence of bankability and different things like that, as far as our own certifications in line, and working with financing companies and folks that are interested in bringing project debt and getting tax equity and things for the owners that do not invest in solar on their own rooftop. So we've been spending that time getting deployments, collecting data, getting certifications, and that's kind of the state of the company and where we are.
where are you getting traction geographically?
Well, we spent a lot of time. We're based in Southern California, so the Southwest is a great market for us. Very high energy rates, lots of large flat industrial rooftops in SoCal in particular. New Mexico, Texas looks really great, and we're moving our way east. So working on projects in your neck of the woods right now, and more towards the East Coast. But it should be noted that we're not quite ready for the hurricane wind areas. So a lot of the East Coast areas with 140, 160 mile an hour winds, those are kind of off limits for PV Booster in this iteration, but we're working to maintain and increase our capabilities for some of those areas. So the Southwest is a great place to start if you have projects out here that look really good. I actually looked at one in Washington for the first time recently, and talk about a boost. That's not one we'll necessarily advertise, but we were producing about 95% more energy out of every panel. But of course, your irradiance is below 1,000 in that region, so tracking makes a lot more sense in some areas like that. But the Southwest is a great place to start.
What is the maximum wind load the system can withstand?
We're at 110 miles an hour, which is most of the country, excluding the East Coast and the Gulf Coast, obviously in hurricane areas. So that's it.
Okay. So what is on the product roadmap? What all do you guys want to change about the tracker as it evolves?
Well, we're really looking to understand exactly what this niche as the CNI space really needs, and hoping to add features and product lines that really make sense for this space. Immediately, we're looking for panel power. We think that's a great way to go to reduce some of the balance of system costs, which we quantify in our price premium for the tracking systems. But something looking to reduce parts, reduce labor costs, add functionality is really the goal. And right now, as well as maximize the effect, the bifacial performance effect, as you see so many of the ground mounted tracker guys doing with the way that they hold panels and how they clamp, and whether the backside has any obstruction. Obviously, in those situations, the reflected energy isn't quite as high. So we've got a lot of room to work, but really just trying to find our place in the industry and the projects that work really well for PV Booster, and take what we do well and capitalize on that to get the most yield and most energy.
What else should we talk about, Austin? I think it's a viable product, and look forward to seeing how you get traction. We do see wind loads sometimes 115. So
Sure.
I don't know if that's going to be a showstopper in Northern Illinois, but
Yeah, well, we definitely recommend, a structural or civil engineer review things. We've put together a pretty extensive body of knowledge. Obviously, Solar Pros will get it really quick, but there are a number of nuances that should be considered through design, installation, service, and operation of the system. And we've tried to quantify that in a really easy to digest, but quite robust body of knowledge. And one of the things that we've done through our FEA analysis for engineering and uplift on wind is really put together the pieces that you need to get it evaluated by an AHJ, and tee up a structural engineer to come through and say, hey, this is going to work for this area, or some of those requirements are a little too high, and PV booster is not the best choice. So it depends, but being a developer and an installer for many years, I understand a lot of the pain that's faced by folks that are looking to get these jobs done, and we've got so many balls in the air that we're trying to juggle that sometimes new technology is a low priority. But taking that experience and really trying to download that into a body of knowledge for folks to understand how to work with this product has been a big initiative for the last year that we've done a pretty good job on. So if in those regions that you have questions, obviously the ASCE 7 standards for wind are pretty easy to find through the wind map. And if something's borderline, I'm happy to help work through the PE that's working on that, and make sure we figure out if this is a good fit.
tell us about manufacturing. Where and in what quantity are you manufacturing?
Sure. Yeah. Most of our manufacturing is domestic, actually. So we have a significant amount of our assembly is done in Southern California, not too far away, and that's where we ship out. And it's a couple day transit for most of the U.S. And actually, proud to say that we manufacture all of the steel components, which you could see from the visual that I put up, is a significant part of the product. That's all manufactured in South Bend, Indiana, with a company called General Sheet Metal and Stamping. So that is the majority of our steel, which comes to the contract manufacturer. And we have a few overseas electronics components, as well as, that's it, that's overseas, that comes to the assembly here, as well as our wire is made domestically. So really the majority of our product is US made, and we're happy to say ships out of SoCal. Obviously, looking to up the amount of megawatts that we have deployed every day. And so we spent a lot of our time making sure our supply chain could really handle what we think is going to be the demand for our product, and brought on someone to manage supply chain and logistics specifically about a year and a half ago. And we've got our manufacturing up to speed. We're running, capable of running at full bore and producing many, many thousands of these units, which about 2,500 is a megawatt, with a goal of tens of thousands here as we're taking orders.
We didn't talk about the control system. Tell us a little bit about that. Is it centralized or decentralized?
So it's centralized in a sense. We have we have an on-site computer, which is usually installed near the inverter area or the mechanical or electrical room, wherever that work is done, called a field control unit. And our FCU is, there's one per project. So it can run thousands of trackers. If they're contiguous buildings or separated buildings, we recommend one per building. And the reason for that is that that's hardwired to Ethernet for reporting and things like that. But if the building loses internet connectivity, the onboard computer is going to continue to operate the system. So there's no issue of that going down if the internet goes down. And that control system is distributed on the rooftop. It's very similar to what you're used to with inverters. They're having combiner boxes up there. We have what we call our tracker distribution boxes, which distribute that to each panel. And those panels are wired up in strings of 30. with a TDB able to handle 3 of those strings, so about 90 per string. So what we do is we match the DC string wiring so you can use the same conduit and follow the same wiring paths, which should make it very, similar to what you're installing otherwise. And that's essentially our control system.
Cool. And as far as monitoring goes, do you have panel level monitoring? I would assume you can achieve that since you have optimizers on each
Yeah.
panel.
Yeah, panel level monitoring is kind of the standard. I guess at this point I would call it tracker level monitoring because we are not monitoring power production. Once we're PV powered, that will be a different case. We'll be able to see exactly how the panel's performing or how the optimizer's performing and what the AC output is. But right now we have our tracker level monitoring, which monitors the number of steps that the tracker takes throughout the day, the general health of the tracker, and it is a very module level system, so that during service and O&M and things like that, you can go out and know exactly which tracker is, say, using more torque than usual to take its steps, and which ones may be not functioning for whatever reason. You know exactly where that is. You're able to pinpoint that and go troubleshoot, or simply swap out a actuator for the system and get you back up and running immediately. So that's one thing about O&M that makes O&M a little bit easier, as well as like we talked about, the actual system is different from what you'd see on the rooftop in a number of ways that allow visual inspections to be simpler. You can see the cable management, and you can see nesting. You can really access anywhere on the rooftop a lot quicker. And with less equipment, that should make your regular O&M visits very, very simple and easy.
And the expected life of the system, what is that?
So the expected life of the system is 30 years. A lot of the steel is actually 50 years. We designed this system to require no modifications once it's up and running. We want this to be something that you don't have to worry about, having a 10-year inverter refurbishment or anything like that. We're really trying to make sure the system lasts that expected life of a normal PV field.
And O&M costs, do you have any data on that?
Yeah, we have an O&M guide that talks about what our additional costs are, and it's about $2 a kilowatt more than what NREL's putting out for the PV, C&I, O&M standards that they have. That's kind of the basis that we took and said, okay, this is what NREL's saying that they think the O&M requirements should be. And so we added in our 6 components that could need O&M work, and did basically statistical distributions of failures and things like that, and looked at that additional corrective cost as well as the preventative maintenance additional cost, which we believe should be easier, but we're not going to make that claim quite yet. And so that's essentially the additional cost, which the O&M guide's a component of our body of knowledge that I'd love to share with anybody who's really interested in those details.
Cool. Well, thank you so much. I really appreciate the introduction. How can people reach out to you?
Yeah, thanks. I'm glad to be here. You can find us on pointloadpower.com, and feel free to reach out through our, web email that you have, as well as find me on LinkedIn, and would love to connect with you, and really interested and love to be a part of this industry, and follow all the news. And guys like Tim do a great job of balancing what's new and also what's practical and what's going on right now. So I'd love to be connected on LinkedIn, but website's a great way to get in touch initially.
You can find all of our recordings on YouTube. Just search for CES NRG Solar Podcast. I'm Tim Montague, your host. Give us a like and a thumbs up, and please subscribe to our channel. And everybody have a great day. Thank you so much. Austin Williams with Point Load Power. Have a great day.
Thanks. Thanks, everybody.